Welcome back. This is lesson 1.2, classifying real numbers. In the past video, I've had videos that talked about classifying rational numbers. We've actually added now a set of numbers in the last video called irrational numbers. So we want to talk about how to classify those numbers and just remind you where other numbers fit in terms of our Venn diagram. So let's take a look. It says, just like you can classify animals based on their characteristics, you can also classify numbers based on a set of shared characteristics. The set of real numbers consists of both rational and irrational numbers. So we have this giant branch called real numbers, and every number that we will discuss today fits in the real number category. There are sets of other numbers that you will learn as you move further along in math that are not real numbers, but everything we're talking about today falls in the real number category. Okay, and then within that category we have rational numbers, numbers that can be written as a fraction, okay, which is my whole space in here. And we have irrational numbers, my numbers that cannot be written in a fraction out there. Example would be like the square root of 21. Can't write it as a fraction because it doesn't have a perfect square answer. Rational numbers, I could have my fractions out here, my decimals, repeating or non-repeating doesn't matter. And then smaller sets, I have my integers. These are my positive or my negative whole numbers, and then just my whole numbers, 1, 2, 3, so on and so forth, all my positive numbers and 0. Okay, so these are all my different sets of numbers, and by putting my numbers into this Venn diagram or into this box, I can figure out what sets these numbers belong to, and that's my goal for today. So let's do this with a few different numbers. So my first example tells me to give all the names that apply to each integer. So I always start with the big boxes and then work my way in. Okay, so square root of 5. There is no perfect square for the square root of 5, so this number has to go in my irrational numbers category. Okay, that means that it is real, because all of my numbers will fit into the real numbers category, and it is also irrational. And since it's irrational, there are no smaller subsets in the irrational category. That's all. It's just real and irrational. Okay, B, negative 12.54. It's rational. I can write it, it has a decimal, so I can turn that decimal into a fraction. It's not an integer though, so it doesn't belong in my integers category. So it just belongs out here somewhere in my rational number section, which means it's real. Okay, and it's rational. C, square root of 81 over 9. Okay, this is kind of a trick question. The square root of 81 has a perfect square, so we need to simplify this first. The square root of 81 is 9, and then 9 over 9 means 9 divided by 9, which is 1. So we're really looking to see where 1 fits into this category. Well, 1 is a real number, it is rational, it is also an integer, and it's also a whole number. So this would go somewhere in my whole number section, which means if it's a whole number, it fits into every larger category as well. So it is a real number, it is a rational number, it is an integer, and it's a whole number. Fits into all the categories. If it's a whole number, it's going to fit into all the bigger categories. Okay, take a second, pause the video, try this on your own for the next problem. So I don't have the chart here. I have it next to me. I'm looking at it right now. If you're doing this, you should always have that chart kind of close by, because then you can kind of place it in the chart and see where it goes, and it helps you see what other categories it fits into. 12 and 1/3. It is rational. Okay, I can turn that into a fraction. We know that 1/3 is 0.3 repeating. Okay, but it's not an integer, so that means it will fit in the real number section. Again, always real. So just write that down every time. And it will fit in the rational number section. A cave explorer was at a depth of negative 12.95. Again, rational. I can make 0.95 a fraction if I wanted to. But it is not an integer. It is not a positive or negative whole number. That means, again, in the same sense, it fits in as a real number and as a rational number. So sometimes they're going to ask us to figure out the set of numbers that best fits something. So what is the best number system to use for a certain topic or idea or whatever it is? So this is what they're asking of us here. Example 2, identify the set of numbers that best fits the scenario. So we want to find the smallest set of numbers that will work. Number 1, the number of people wearing shorts in a classroom. Well, there could be 1 person, 2 people, 3 people, but there's not going to be a negative, so it's not going to be, or it's not going to be a fraction of a person. It's not going to be an irrational number. The square root of 7 people can't be wearing shorts. It's going to be 1, 2, 3, and those are our whole numbers. So that would be the best set. So it actually would fit integers. It would fit rational. It would fit real, but they're not the best. They're not the most broken down version of that number. Number 2 says the amount of money spent at a store. The amount of money spent, it's going to be probably a negative amount of money, right? You're spending money, that's a negative. That fits in with my integers. If you said, hey, I'm spending a positive amount of money, I'm spending $30, I didn't spend negative $30, that's actually whole numbers, that probably would work too. You could explain it either way. Number 3, the circumference of a circle. We need to remember we multiply by pi, which is an irrational number. Okay, so if we multiply by an irrational number, we're going to get another irrational number. So that is actually irrational. If you said, hey, I'm using 3.14 for pi, then you would end up with a rational number. But anytime you multiply by an irrational number, you just get another irrational number. Take a second, try the next ones on your own, come back and we'll discuss what categories they actually fit into. So hopefully you paused the video, came back. We're going to identify the sets of numbers that best describes each of these 2 situations. The amount of time remaining in a movie in seconds. If you've ever seen that thing, that the ticker or whatever they call it at the bottom tells you how much time is remaining. It always is very super specific with its decimal points. It could be like 5.2 seconds. So I'm going to put that into the rational number category instead of the integer. The depth below the ocean a submarine explores as a whole number. Well, the depth is, it's negative feet, right? You don't go positive feet in a submarine, you go down. So they're going to be our integers, right? Our positive and negative, and it says whole number here. So that tells me it's not 5.5 feet, it's negative 5 feet. Okay. These ones sometimes can be a little bit open for some gray area or some interpretation depending on how you read the statement, but the categories are the categories. Whole numbers, 0, 1, 2, 3, 4, my counting numbers plus 0. Integers, my positive and my negative whole numbers. Rational numbers, any numbers that can be written as a fraction. Decimals are in there, fractions are in there, mixed numbers. And then irrational are my square roots that are not perfect squares. And pi. Pi is also in there. Okay. If you have any confusion, please ask. Hopefully you have the notes. If not, click the link for my Teacher Pay Teacher page below. Please leave a comment if there's anything you're confused about, or do whatever you have to do.